Okay, so a very good evening to you and welcome back to the continuation of our network defense training. We are in the final week of our training. Hopefully this week we should be rounding up. So I encourage all those that have not done their online activities, please try and do so within the week. And those who have not been catching up, you have an opportunity to do so. So after today's class, we just have two or three more sessions, and then we are done for the program. Okay. Having said that, today we'll be looking at Module 7. Module 7 is talking about cloud security. So we'll be looking at the concept of cloud and cloud security. What is this cloud all about? What is this cloud all about, and how do we secure it? We'll be looking at the concept of virtualization and cloud computing. And then we will explain the domains of cloud security, and then also explain the mitigation of threats to the cloud platform infrastructure. We'll look at what the cloud infrastructure is. We'll also look at cloud application security, then cloud data security, then we'll look at how we can protect our virtual machine instances, okay? So let's dive into virtualization and cloud computing. Virtualization benefits an organization by decreasing the number of physical machines, e.g. servers and workstations required in an IT environment. For those of us that this is new to us, you may want to find out what this means. On a normal day, if you are building a server room or a data center, let's assume this is your data center or your server room. In your server room, you will have multiple racks. You have multiple, maybe this is rack 1, you have rack 2, you have rack 3, and so on and so forth. In rack 1, you will have maybe servers, server 1, server 2, server 3. Rack 2, maybe you have your switch, your router, and things like that. Rack 4, you will have continuation of your servers, and things like that. Now, for you to run this, number one, you will need power. You will need power. Ensure that there is steady power. Number two, you will need an expert in data center management. Number three, you will need a network administrator. Number four, you will need a system administrator or a server administrator. And then you will need another person that will manage the applications, which means the cost of setting up and managing all these servers in your organization is capital intensive. But it is very worthwhile. It is very worthwhile, but it is capital intensive. However, the concept of virtualization is saying, instead of having inside this server room, all in all, instead of having maybe 20 servers, you can have only one server with a high specification, and inside that one server, you will have 20 servers inside. That is just what it means. Or instead of having 20 physical servers, you can have 5 physical servers or 4 physical servers, and then you would be able to have less resources. Additionally, the concept of cloud is to say, instead of having it physically there, you can host it in the cloud. So the whole idea is decreasing the number of physical machines so that you can be able to improve your services. Now, for you to achieve that, you need what we call the hypervisor, okay? You need what we call the hypervisor. You want to know, what is this hypervisor? and what is its function when it comes to cloud hosting or virtualization, generally the concept of virtualization. Now, remember that when we are talking about virtualization, we are talking about having one physical device and then multiple logical systems. So instead of having one server for my mail, another server for my web, another server for FTP, another server for maybe files, another server for database, another server for syslog, another server for NMS, and things like that. You can just have maybe one physical server or two. Then inside it, you will have multiple. So this hypervisor is the guy that helps you to have these services. That's all. So it is a software or hardware program that allows you to run multiple independent operating systems on one physical server. So you can have Linux on one, you have Windows on one, you can have Mac on another, can have whatever it is you want. Now, this hypervisor that works in creating a virtual machine, we have two types. We have what we call the type 1 hypervisor, and we have what we call the type 2 hypervisor. What is the difference between the two? The type 1 hypervisor, usually they call it the hardware virtualization. It means that if you have a system, maybe a desktop or a server, and you install a type 1 hypervisor, that software, that hypervisor will commandeer the entire system. It will take over the hardware resources of the entire system, which means you cannot install any other operating system directly on the hardware. You cannot do that. So the type 1 hypervisor, the guest operating system runs directly on the hardware platform under the control of the host system. But for the type 2 hypervisor, it is called the hosted virtualization. An application running on the host machine is used to create virtual machines that consist entirely of software and contains no hardware component. So maybe for instance, you have what do we call it? Maybe a Windows operating system. Then you can have a type 2 hypervisor installed on that Windows operating system. So if you install it on that Windows operating system, then you can have virtualized softwares. So virtual machine environments use an operating system so that they need to be patched. Then there's what they call containers. You see these words, you're going to be seeing them very often. You'll be seeing virtual machine, if the type 1 hypervisor, type 2 hypervisor. When they say virtual machine, it means it is like an independent system, operating system that you have installed on a particular system. And that system you have allocated RAM, processor, and whatever inside. How about a container? Unlike a virtual machine, a container consists of just the application and its dependencies. A container uses an engine for operating system emulation. Docker is an open platform that uses OS-level virtualization to deliver solutions in packages. That is like the container. So you see, the container is basically related to the application. Basically, that is it. So you can easily move the container around and the application will still run. Specialized softwares such like the Kubernetes allowed you to manage your containers. So if a user or application has elevated privileges within a container, the underlying operating system can be compromised. That is it. So you see, we've looked at virtual machine, we've looked at containers. Then there is the virtual desktop infrastructure, VDI. Virtual desktop infrastructure. User desktop environments can be stored remotely on a server using thin clients or virtual desktop. This makes it easy quickly to create, delete, copy archives, or even download configurations over the network. So desktop virtualization requires a high availability of storage capacity. That is why sometimes, even in your Windows, there is an application called Remote Desktop Connection, where you use that application to remotely log into another machine that is located in another place. So cloud-based technologies enable organizations like Apollo to access computing storage, softwares, and servers through the internet. It moves the technology component from organization to the cloud provider. So now let's recap. The three main components services, which are collectively known as XaaS, all right? We're going to now look at the technology in the cloud hosting. There's what we call the SaaS, which is software as a service. There's another one, PaaS, platform as a service. There's another one, IaaS, infrastructure as a service. So if you look at all of these solutions provided as a service, which means the software as a service allows users to create application softwares and database. You know, cloud providers manage the infrastructure while you just store your data in the cloud server. That is it. For instance, if you have Gmail, that's a software as a service. If you have what do you call it, Google Drive, it's a software as a service. If you're using Microsoft OneDrive, you know, software as a service. What they're saying is that somebody has built the application. Somebody has built the software. Somebody has hosted the software in the cloud. Your own is just you are using the service, that software. That's all. The email, Gmail you are using is software as a service. The Microsoft 365 you're using is software as a service. They are all softwares and they are being provided to you as a service. The next one is platform as a service. Now, you see, in this one, the platform lets an organization remotely access the development tools and services used to deliver such applications on subscription basis. So this one is not just about the software. It is about the platform that helps the programmer to build the application. So in this case, for software as a service, mostly users can make use of that. For platform as a service, you need like programmers or software developers. So they just provide the enabling environment for you to build your own software. That is what happens there. You understand? And then the other one is infrastructure as a service. With infrastructure as a service, they're just giving you the entire infrastructure. They're giving you the entire hardware, the hardware system in itself. That's what they're giving you. So it's like, say, I need a system with 16 core processors, 32 gig RAM, 1 terabyte storage. It's a system. So that's what they're giving you, blank. You are the one to install the platform. You are the one to install the software. So those are the three. So the infrastructure as a service provides virtualized computing resources over the internet. The provider hosts the hardware, software servers, and storage components, and the user is subscription to these resources. Cloud computing classifications are based on how the service models are deployed. Sorry about that. I think the network just glitched. Let's continue. Okay. Okay, just a minute. Let me ensure that that doesn't happen again. Minute. Okay, so I think we're good. So when it comes to cloud computing, we say cloud computing classifications are based on how the service models are actually displayed. So we have what we call the private cloud, and we have what we call the public cloud. Now, the private cloud, also called an intranet or internal corporate network or enterprise cloud, is a private cloud on a which is hosted on a private platform. Okay, a private cloud offers an organization more control over its data, but it may be more expensive than other cloud services due to infrastructure maintenance and administration. Now, what do we mean by this? It is also a cloud solution. The only difference is that it is private. That's all. The only difference is that it's private. Okay? And when we say something is private, it's exclusive. It cannot be accessed by everybody on the internet. All right? So because of that, it is more secure, but it's more expensive also. Then you have the public cloud. A public cloud is hosted by a service provider at an offsite facility. Users pay a monthly or yearly usage fee to access the cloud. This option costs the organization less for infrastructure, maintenance, and administration. However, the organization has less control over the data. Now, when we are saying this cloud, what is this cloud? What is this cloud? It's not anything new. This cloud is just basically a data center somebody has built somewhere, a server room or a data center somebody has built everywhere, somewhere. You don't have the money to be able to build your own. You don't have the expertise to maintain your own. Yeah? And probably the services that you need does not warrant you to set up an entire server room in order to run the services that you want to run. But somebody else has the money, has the expertise, and requires a lot of those facilities to run. So that person sets up a server room or a data center and then connects it to the internet so that it opens for subscription for people to be able to pay. And the money you are paying helps the person to keep the place running. That is just all about this cloud. It's just that it's not within your reach. It is remote. It's somewhere else. Okay. So we have private cloud, you have public cloud, then you have hybrid. Hybrid cloud combines the private and the public cloud and offering control of organizational data, which is still hosted in a public cloud. Then you have community cloud. A community cloud is a collective effort in which more than one organization share and use the same platform. This type of cloud is geared towards the need of an industry such as healthcare or energy. Okay, another very common one is in the educational sector. You can decide to say, oh, all the tertiary institutions within Nigeria or within a particular country, we want to be hosting certain resources in the cloud. So we will purchase a data center. Maybe we will fund one university to host this data center and ensure it's running. Then every other university will have access to that particular data center. Okay? Now, let's look at the concept of fog and edge computing. The explosion of IoT devices. IoT simply means Internet of Things. And the IoT devices, we're looking at a network setup where everything is connected. Your fridge, your lighting, your curtain, your smart TV, your smart car, your smartwatch, where you have all these devices connected to the network. So the explosion of IoT devices has led to fog and edge computing. So fog computing distributes computing between the devices and the data center. It plays a crucial role in applications where milliseconds matter, such as autonomous vehicles, airlines, and manufacturing applications. So milliseconds matters in all those very well. So in fog computing, data is processed within an IoT gateway or a fog node, which is situated within the local area network. So it is also a form of cloud computing because the management of all these IoT devices are managed in that particular server. So in the edge computing, the data is processed on the device or sensor without being transferred to a data center. You see, that's the difference. For the fog, the devices are managed remotely in the data center. In the data center. But the fog, the edge, the devices are managed within the device itself. So what are the threats that we can have to cloud computing? So cloud computing is susceptible to many of the same threats that affect physical enterprise. However, the cloud environment also introducing a unique threat. For instance, if a threat actor successfully compromises a cloud resource, they could do the following. They could use the cloud computing resource to target other online entities, host malware or respected cloud providers that will appear harmless or even legitimate. Abuse the cloud services to launch DDoS attack, host pirated content, and even send email spams and conduct phishing campaigns. The point is that with cloud computing, your data is managed by another server. It's hosted somewhere, managed by another server. That is it. So if somebody gets access to it, then it can do a lot of damage. The following lists, some threats associated with cloud computing. One is data breach. This occurs when protected, sensitive data is accessed by an unorganized entity. Then cloud misconfiguration. This occurs when the cloud computing resource is set up incorrectly, making it vulnerable to attack. Then you have poor cloud security architecture strategy. So private cloud security is the responsibility of the organization itself. However, security for public clouds, hybrid clouds, and community clouds become a shared responsibility between the organization and the provider itself. So this can introduce vulnerabilities in the cloud security architecture. If it is not fully understood or correctly implemented. Another one is compromised account credentials. Now, this usually occurs when user accounts or access privileges are not properly secured and are hijacked by threat actors. So this can lead to a major security threat if the account has high privileges. For example, maybe it's maybe a super user account or administrator account. So in public clouds, a service account has highest privilege of accessing and managing cloud access. So a hijacked service account will enable the threat actor to control all the cloud resources that are there. Insider threats. Okay, so this occurs when an employee or contractor or a business partner maliciously or unintentionally compromise the cloud service. That's why you need to be very careful who you give the admin rights to. Then, insecure software user interface or application. So cloud computing uses software user interface and APIs for customers to interact with. For instance, let's say banks. Banks have, what do they call it now? Their software, mobile apps. So those mobile apps have APIs that connect to the main servers. So these interfaces are the most exposed points to the internet, and therefore they are targets for threat actors, right? So limited cloud usage visibility. This occurs when the cloud client does not have full visibility into the cloud service, making the identification of safe or malicious files more difficult. So let's look at domains of cloud security, okay? There are many resources available promoting cloud security. So we'll look at some of them. A widely respected and referenced resource is the Security Guide for Critical Areas of Focus in Cloud Computing version 4 document. So another one is developed by the Cloud Security Alliance, that's the CSA. It promotes best practice to provide security assurance within the cloud computing domains. Then we also have specifically the document that covers 14 domains of the cloud security. So now let's look at the domains. The first one is the cloud computing concept architectures. And this domain defines cloud computing terminologies and details the overall logical and architectural framework used in the security guidance document. The second one is the governance and enterprise risk management. This domain describes 4 areas impacted by cloud computing, which is the governance, the risk, the enterprise risk management, information risk management, and information security. Then you have the legal issues, contract and electronic discovery domain, which describe legal issues associated with cloud computing, including the moving of data to the cloud, all right? Contracting within cloud service provider and handling the electronic discovery requests in litigation. Then you have the compliance and audit management, which describe challenges of delivering, measuring, and communicating compliances when organizations migrate from traditional data centers to the cloud. So you see, moving into the cloud, there are a lot of things that are involved, but you need to know very well what you want. Then you have the domain of information governance. The domain describes the need to ensure that the use of data and information complies with organizational policies, standards, and strategies, including regulatory, contractual, and business objectives. Then you have the management plane and business continuity. The domain describes the need to secure the cloud computing management plane, okay? Particularly, it also describes the business continuity and disaster recovery procedures to be used by the cloud provider and also the cloud clients. You also have the security as a service. The domain covers continually evolving security services delivered from the cloud. You see, we're looking at all these domains because in each of these domains, there are experts. One person does not know it all. Absolutely no. One person does not know it all. So what happens is that you can decide to say, okay, in cloud security, I want to focus on security as a service, or I want to focus on infrastructure security, or I want to focus on virtualization and containers, or incident response, or application security. So each one of these is a domain. You can pick it and then it's an entire course, an entire domain on its own. So infrastructure security, the domain describes cloud-specific aspect of infrastructure security and the foundation for operating security in the cloud. Then you have virtualization and containers. The domain describes the need to secure the virtualization technology and virtual assets, which are the foundation of cloud computing. You have incident response. The domain describes the critical aspect of incident response, including the incident response lifecycle and considerations for responders as they work in the cloud environment. Then you have the application security. The domain provides guidance on how to securely build and deploy applications in the cloud. All right, especially platform as a service and then infrastructure as a service. You then have the data security and encryption. Data security should be risk-based since it's not appropriate to secure everything equally. The domain describes those controls related to securing the data itself, of which encryption is one of the most important. Then you have the identity, entitlement, and access management. The domain describes how cloud identity is different than traditional identity management. So then finally, you have what they call related technologies. So this domain provides background recommendations for technologies that rely nearly exclusively on cloud computing to operate, and for technologies that do not necessarily rely on cloud, but are commonly seen in cloud deployments. Okay? So what we have seen in these domains is just to open your mind on the different aspects of cloud security that you want to look at if you want to go into cloud security. So you see, network defense is all-rounder. It's a very, very, very wide area of coverage. Very wide area of coverage. Okay, so we have looked at firewall the other day. We have looked at access control the other day. Now we're looking at cloud security, and within the cloud security itself, there are different domains. Now, let's look at the infrastructure security in the cloud. Okay. Now, the infrastructure security domain describes cloud-specific aspect of infrastructure security and the foundation for operating securely in the cloud. Cloud infrastructure is the foundation on which virtualized cloud resources such as computing, networking, and data storage are built in and deployed. Because we are looking at the concept whereby I have one server, I can virtualize it into 20. But the user who is requesting for the services in the cloud, I am only giving him a virtualized environment without him knowing such. As far as it's concerned, it's a system because it has a RAM, it has a hard drive, has a processor, it has an operating system, it has an IP address, it has a public IP address, it has everything that a normal system has. Okay? So there are two major layers of infrastructure in cloud computing. We have the physical layer and the logical infrastructure. So in the physical and logical compute, we're looking at network and storage are combined to create a cloud. We'll look at it soon. Then in the virtual infrastructure is managed by a cloud user. That is the compute network and storage assets they access from the resource pools. So in simple terms, for those of you who probably are used to this, there's what we call dedicated hosting, and then there's what they call shared hosting, if you're used to websites or hosting of website and things like that. So when you are saying you're using a dedicated hosting, everything that is given to you is exclusive to you. It's like you are given an entire VM. All right? You are given 4 CPUs, and that 4 CPUs, you are the only one using it. You are using 128 gig of RAM or 32 gig of RAM, you are the only one using it. You are giving maybe 10 gig of storage, you are the only one using it. You are so bandwidth, you are the one using it. But the other one, which is shared, which we are talking about virtual infrastructure here, we're looking at a scenario where, let's say, a particular system, you have 10 CPUs, 32 gig RAM, and so on and so forth. But the users that are using it are sharing the same resource. You cannot have at a particular time T, one person is using everything all the time. No. In most cases, people that use that shared hosting do not run too much of this thing. So due to the nature of cloud computing, traditional infrastructure security measure based on the control of physical communication path and insertion of security appliance do not work. Custom cloud security tools include virtual appliances and software agents that are used to secure environments. However, these tools may introduce bottlenecks when accessing resource or lead to processor overloading. Therefore, the use of virtual appliances should be carefully evaluated and deployed. So we have the software-defined network, which enables new type of security control to provide an overall gain for network security enabling. So easy network isolation without constraint of physical hardware, because we're seeing software-defined network. How do I put it? You know, the concept of a network, generally, you have your end devices, you have your intermediary devices, and then you have your network medium, which is okay. That's physically you're setting up a network. In this case, you are like setting it up, you're setting it up virtually. Your VMs are like the end devices in this case, okay? Now, you will need an intermediary device and network media to set up. So you are doing all these things using a software. There's a software that can help you to manage your network. So the SDN firewall appliances applied to asset based on more flexible criteria than even hardware firewalls, which means instead of buying a hardware firewall, you can just have the software part of it. You know, those of you that use Linux, you can set up firewall on Linux. Even those of you that use Windows, for Windows Server editions, you can build up a firewall. So the firewall is just permit and deny, like we see. It's just permit this traffic, deny this one, permit this one, deny this one. And that's just what it is. So you can have the software that controls that. Cloud computing involves cloud clients and cloud service providers. Therefore, cloud security works in a shared responsibility model. So, a cloud service provider is responsible for the cloud services to the client, but the client is responsible for the rest of the services, which is true. So if the cloud provider provides for you the service you are requesting for, if you are saying infrastructure as a service, all he does is that provide the infrastructure and it's done. Ensure the infrastructure is always up and running and it's done. What he put inside, whether it's working or not, is not his problem. Whether it's hacked or not, is not his problem. But if what he's providing is software as a service, his job is to provide to ensure that the software is working. Everything about the software is okay. And so we're saying a cloud service provider is responsible for the cloud services to that particular client. Now, let's look at this comparison and the responsibilities, okay? We say here that the following table displays the security implementation responsibility between a client and a cloud service provider in different cloud service models. The models are infrastructure as a service. Okay, we have the on-premises. On-premises means that you build and host your server room physically there and then. Infrastructure as a service, somebody has built it and you are requesting for a service for you to gain access to a hardware. Platform as a service is a cloud solution that you as a programmer, you need a platform to build your application. Software as a service, he has built the application and he's providing you the service. So let's look at when it comes to data. We're looking at responsibilities now. When it comes to security responsibility and it comes to data, whether it is on-prem, is the job of the client. Whether it is any of these other models, is the job of the client to protect his data. You, the client, you are to protect. So it's like your email. All the content in your email is your job to protect it. Then endpoints. Endpoints. It is for on-premises is the client, infrastructure is a client, platform is a client, but software as a service is shared. Why is it shared? It's shared because the endpoint deals with the device itself. So you as the service provider, you are using it. You're using that this thing, and you need to protect it. The same with the client. Then identity management. For on-prem is the client, infrastructure is the client, and platform as a service is shared, software as a service is shared. How about the application? On-prem is client, infrastructure is client. Now, observe something. All these responsibilities, when it comes to on-prem, everything is the job of the client. Why is it so? Because it's the client that set up the on-prem. It's the client that set up the server room. So it's his job to protect the data, the endpoint, identity management, application, network control, operating system, infrastructure. If there's any issue, it's his job to do it. Now, look at infrastructure as a service. Everything is also the job of the client with the except of physical infrastructure. Why? Because the service provider only just provides you the infrastructure, ensures that it is running. Every other thing is your wahala. So that's why it is the job of the CSP here. Now, when it comes to platform as a service, it's only these two that is the job of the client, which is data and the endpoints. But you see, these ones are shared. We're talking about identity management, application, and network control. They are shared. And then, but the operating system and the infrastructure is managed by the client. That the service provider is the one that manages that one. And then if you look at the software as a service, for the software as a service, it is only the client only manages the data. That is the only one. The other one is shared. That is the endpoint and identity management shared. The remaining thing is the job of the service provider. So organizations may permit users to download unknown software tools. Unsanctioned apps may increase employee productivity by permitting them to download and use their favorite software tools. Unmonitored apps can create security gaps and blind spots. What are all these things? They're just policies, rules that you can set up in your organization to help you manage this. Established well-defined company security policies and educating users are effective ways to manage unknown apps. Now, how about layered security? When you are talking about layered security, like we talked about the other day, you are looking at a security where you put a security upon another security, upon another security, upon another security. And so cloud resources can be viewed in 4 layers. There's hardware, and you will have a security for it. Infrastructure, you have a security for it. Platform, and you will have a security for it. And then application, and you have a security for it. So the defense in-depth strategies can be applied to each of these layers. Now, some of the options include the cloud platform, to typically have inbuilt security at the platform level to conduct client cloud resources. A virtual private cloud allocates private subnets that are logically isolated from the internet. That's where they give like local IPs and things like that. So flow logs are also used to monitor traffic that crosses individual network interfaces. Then VPN are used to provide remote user access to the cloud resources, as well as site-to-site connections, right? Identity and access management services provide user credential management and user authentication. Remember, we talked about this identity access when we were talking about access control, and particularly we were discussing the AAA. Okay. Micro-segmentation, which is also referred to as hypersegmentation. So micro-segmentation leverages virtual network topologies to run multiple smaller and more isolated networks without incurring additional hardware costs. So because the networks are entirely defined in software without any of the traditional addressing issues, it is far more feasible to run these multiple software-defined network environments. Microsegmentation techniques allow for more granular control of security for traffic and workflows within the cloud. So what is the point here generally? Breaking your network into small and then managing them. Even if there's a security breach, it is limited within one particular segment and it is easy to manage. Okay. Cloud application security. To maintain security at all stages of application development, the following robust process needs to be followed. Okay, developing and testing. Software is developed and updated in an development environment where it can be developed, tested, and debugged before it is being deployed. Version control software helps to track and manage changes to the software code. Developers may also work in a sandbox environment so that code is not overwritten as they develop it. So during testing, developers look at how the code interacts with the normal environment. So the area of app development is what we're talking about in this case. And developing it where? Developing it in the cloud. Gone are the days where you need to install a compiler on your machine, you need to install a programming language, and then you begin to work on creating your app. It still works very well and it's commendable. But we're saying that in the cloud, there are platforms that you can actually develop the same application, if not better, because you have variety of tools that you can be able to use to achieve that. And if you're doing that, it's going to help you in provisioning and deprovisioning, meaning that as you create the software, if there are bugs, you correct it online. Okay, where there are challenges, you make necessary correction. So provisioning is creation or updating the software. All right. So Staging and production. Staging environment should closely match the organization's production environment. When we talked about staging environment, you are trying to say like a temporary platform where you want to run or test run this particular application. So I've built an application. Before I release it for users to begin to consume, I will have to put it somewhere like a staging environment and then continue to test it. And I invite people to test it. If there are bugs, if there are errors, if there are issues, then I fix it. It's when you have finished all these issues and fixing it, then you relate it outside there. How about securing your coding techniques? So when coding applications, developers use several techniques to validate that all security requirements must be met. And one of these is normalization. Very, very common when you're a programmer, okay? Normalization is used to organize data in a database and helps to maintain data integrity. Normalization converts an input string into its simplest known form to ensure that all the strings have unique binary representation and that any malicious input is identified. Okay, so that's normalization. Stored procedure is a group of precompiled SQL. SQL means structured queried language. It's a language or is a rule you use in database management. You want to manage your database, create record, create roles, manage your database. Okay. So if you use a stored procedure to accept input parameters from clients using different input data, you reduce network traffic and get faster results. Okay, we have obfuscation and camouflage. The developer can also use obfuscation and camouflage to prevent software from being reverse engineered. When you say reverse engineer, is you engineer something, that means you build something. Reverse engineer means that you take it down, you destroy it. Okay. Code reuse means using existing software to build a new software. Some programmers have built, let's say, a school management system, for instance. And since they have that application, if another school wants a school management system, they don't need to go and start building from scratch. You just pick that one, dust it, and then customize it to the need of the school. Okay, that's where we're saying code reuse. So you can reuse the codes. In other cases, you can create functions and call them as you build the other modules in your application. Okay, the SDK, the third-party libraries and software development kits provide a repository of useful code to make application development faster and even cheaper. The downside is that any vulnerabilities in SDKs or third-party libraries can potentially affect many applications. Okay? So, we're almost done. Controlling the data input process is key to determining database integrity. Many attacks run against a database and insert malinformed data. So somebody is attacking you, he has to go and find and install a mole inside your database. Okay. So automated input attacks examples. Customer may fill out a web application form to subscribe for a newsletter. Another attacker may do that. And then a database application normally generates and sends email confirmation back to the customer. An attacker can do that. When customer receive an email with a URL link, to confirm their subscription, attackers have modified the URL. That's another way. These modifications can change the username, email address, or even subscription status of the customer when they click to confirm their subscription. So hackers can automate their attack to flood the web applications with thousands of invalid subscriber and newsletters database. So what are the validation rules? Validation rules check that data falls within the parameter defined by the database designer. Okay, so the database has defined certain parameters. So a validation rule helps to ensure the completeness, accuracy, and consistency of the data. The criteria used in a validation rule includes size, format, consistency, range, and then check digits. Okay, and then check digits. Integrity check. An integrity check can measure the consistency of data in a file, all right? Picture, record, to ensure that it is not corrupted. The integrity performs what we call a hash function. What is this hash function? It is just, okay, let me use an example. It's just like saying, I have a pot and then I put water inside. Inside this pot and inside this water, then I go and weigh it. I weigh it and then it gives me 15.9 grams. And then I carried this, I sent somebody, I said, please go and bring this water for me and bring it here. And the person came all the way, picked the water, and then came back. Now, how am I sure that the water did not pour on the road? Or how am I sure that he did not add something? How can I validate or check the integrity to ensure that the content that is there is the same content here? The only way is for me to run the same measurement again. If I get 15.9 for 9 grams, then it means that I have a high integrity. Nothing was added, nothing was taken off. So this hash function works like that. You create a document or you have a document. When you have a document, there's a software you use to create hash to secure it. What it does is that it weighs that document and then creates a particular, it encrypts the document and creates a particular hashing value. It creates a particular hashing value. Now, if there is any change in that document, even if it is comma, or even a space, or even is anything that is being removed or added, the hash value will change. The hash value will change. So the integrity check is what we're saying here. So if you look at this, for instance, you have your data. It may be your files, your emails, your pictures, and things like that. And then this data is now converted to binary and summed. That's where you are creating your hash, whatever. So is converted to binary, and then a sum is given. Then from there, a checksum is calculated. That means they calculate for errors, they calculate for everything and ensure that there is a particular value for it. Once it's calculated, then the data is now stored. The data now is stored and kept. Or if you don't want to keep it, you intend to transmit it or you send it somewhere, fine. Then you now send it. Once you send it, the checksum is calculated. And then what happens? There is a comparison here. What is being compared? This one here, when this checksum is calculated here, A value is sent here. When this guy is going to be sent, the value is recalculated and then they compare it. If they compare it and see that it is the same value, then they say it has passed the integrity. The content has not been altered. But if it does not pass, it is not the same thing, then you say the content has been altered. So that's how the checksum works. It verifies the integrity of the files or the string of characters before and after transfer devices across a local network or even the internet. All right. So we've talked about using the hash function and things like that. All right. So cloud data security. The state of data domain describes related to securing the data itself, to which the encryption and the hashing are the most important. Customer data should be protected in the following way. We have what we call data at rest and we have data in motion. Data at rest is where your information is stored in your hard drive and kept. Data in motion means that you are transmitting the data. So when your data is at rest, how do you protect it? Okay, it should be protected. So data is in its state when no user or process is accessing or requesting or even amending it. That is when it's at rest. Data is at rest. Data at rest can be stored on local devices such as hard disk in a computer or even a centralized network. All right. In cloud computing, data at rest can be stored in cloud and is accessible from any computer connected to the internet. So all data that is not in transit or in process is considered data at rest. So if I copy something into my flash, it's data at rest. Okay. Data in transit, on the other side, refers to data which is being transmitted. And in some cases, because data, you are transmitting the data, somebody would want to intercept that data and alter the content. Okay? So the data that is not at rest nor is being processed is data in transit. The transaction or transmission should be within a single server along its motherboard's bus line between devices on a single network or between networks that are possibly across the internet. Simply, when the data is moving from one point to the other, is data in motion. Okay? Then you have data in process. This refers to data during initial input and modification. Okay, computation or output. Data is in this state when it is neither in transit nor at rest. Okay, so that is it. Maybe when you are creating the data or when you're imputing it and things like that. Okay. Cryptography. Cryptography is the science of making and breaking secret codes. So by storing and transmitting encrypted data, only the intended recipient can read or process it. So you encrypt the data. I am the sender, so I now zip it, I encrypt it. So if the receiver receives it, I have to give him the code to decode. So encryption converts. Encryption is the process of scrambling this data so that unauthorized people cannot easily read it. It is when enabling encryption, readable data is called plain text, while encrypted data is called ciphertext. Ciphertext. So if the plain text says, I am hungry, for instance, If you see the cipher for that one, it looks nothing like I am hungry. It looks something different. Okay? So that's where encryption comes in. So encryption converts the plain text readable message to ciphertext, which is unreadable, disguised message. So encryption reverses the process. All right. Encryption requires a key, which plays a crucial role in encrypting and decrypting the message. Okay. There are two classes of encryption algorithms. One, the symmetric encryption algorithm, then the asymmetric algorithm. Now, what is the difference between the two? The symmetric encryption uses the same pre-shared key to encrypt and decrypt data. So, for instance, if I encrypt this data, the key or the password I use to secure this data or to encrypt this data is the same thing that you use at the other end. The advanced encryption standard, AES, which we use in our wireless routers or APs, is symmetric encryption algorithm that has a fixed block size of 128 bits. So anytime you are configuring wireless or Wi-Fi, you see that the password they're using is AES, which means Advanced Encryption Standard. The asymmetric encryption use one key for encryption that is different from the key that is used for decryption. So the asymmetric algorithm include the RSA, the Diffie-Hellman, and so on and so forth. So the key element is that it's the husband that encrypts. What decrypts it is the wife. Okay? Hashing, like I have explained to you, it is a tool that ensures data integrity by taking the binary data and producing a fixed length of representation called a hash value. That's all that it does. It just picks data, converts it into a hash value, and then stores that value. If you come another time, you now access the data, then you will do the same hash value. If it gives you exactly, then it has not been tampered. So hash functions are a one-way function used to verify and ensure data integrity. The integrity is to say that the content has not been altered. It works by using cryptographic hashing functions to replace plain text password or even encryption keys. A cryptographic hash function has the following properties. The input can be any length, and things like that. Protecting our VMs. Virtual machines or virtual instances, just like physical computers, require patches, updates, anti-malwares, to be protected from external threats. So the cloud offers additional security options depending on the specific cloud tools in the cloud platform to protect the VMs. Then you have the planned subnet placement and the disable unneeded port and service. These are some ways that you can do to protect your VMs. Now, when you say the planned subnet replacement, carefully choose the subnet for each instance so that it can only be necessary to access it to the outside world. What it means is that when you are coming to do your IP allocation, don't use the same family name for all of them. If you use the same family name, which is the same subnet for all of them, they are all within the same network. If they're able to reach one, then it is easy to reach the others. And then you are supposed to disable ports that you do not need, unneeded ports. Okay? Remember, we're looking at protecting our VMs. We said you plan subnet replacements, then you disable unused ports, then you enforce account management policies. The operating system in a virtual machine has default user accounts. You need to change that. You need to replace that. Okay. So deactivate all those accounts and make sure that you create a fresh one. Install antivirus, anti-malware softwares and keep it updated. Okay. So this can be accomplished through the virtual machine operating system, or it might be available as a service from the cloud platform. And then install host-based software firewalls for intrusion detection system and prevention system. So how do you protect your VM from sprawl attacks? Create VM instances in the cloud is a relatively easy process. This may lead to VM sprawl issue where an organization has many VM instances that are not properly managed. In this burning instance, are not monitored and maintained, they eventually become outdated and vulnerable to attack. So a cloud computing client could implement a policy to log and audit cloud resources being used. So VM sprawl do not only present potential risk, but it also consumes cloud services unnecessarily, such as the VM instances, the storage, the unassigned public IP addresses, and so on and so forth. Okay, so on and so forth. So this is the end of chapter 7, cloud security. So what we have looked at in this particular topic is the concept that we have in the cloud. Cloud is a data center that is located somewhere for people to be able to access remotely. And in that data center, you want to maximize the usage of the hardware facilities, so you create virtualization, meaning that you create other small machines inside the main machine. Once you do that, that means you are creating virtualizations. Okay, and then by doing so, there are vulnerabilities that comes with it. There are challenges that comes with it, and we're able to look at how to mitigate and protect against that. So this is where we'll draw the curtain for today's class. Any question? If there's any question, it will be good for us to know. Any question before we call it a day? Once again, for those of you that join in much later, we said in the beginning of the class that this week is the last week for this training. Okay, so we'll be rounding up this week. So if you have not done any of your online assignments, please try and do that. If you can do that today, that will go a long way. If you can't do it, make sure that you do it before the course ends. Okay, so basically that is it. So thank you very much, and have a lovely night. I'll be uploading the recording so that you can follow up what you have missed. So good night.
Good night.